Welcome to the webinar, everyone. This webinar talks about future-proofing your business. That means creating a sustainable business model that stands the test of time. Since March, the world has faced significant change with the spread of COVID-19 that has tested even the most resilient business models across all countries and all industries. As we start to enter the next phase of the new normal, it is important that businesses review and implement sustainable business practices, and that is what our panel will discuss today. You'll hear from some of SNC-Lavalin's most senior leaders representing diverse industries and projects. Join me in welcoming our panel, which consists of Dale Clark, Executive Vice President of Infrastructure Services, Sarah Jane Stewart, Head of Global Corporate Sustainability for SNC-Lavalin, Sebastian Musso, Vice President of Power Grid and Industrial Solutions, Kathy Cottrell, Senior Director from Nuclear, and Patrick Zeker, Vice President of Mining and Metallurgy. After our panel members have presented, we will be taking questions, so I encourage you to submit questions during the presentation and we'll do our best to get to them at the Q&A session. So to kick things off, we welcome Sarah Jane Stewart.
Good morning, everyone. Good afternoon. My name is Sarah Jane Stewart and I'm the Global Head of Sustainability for SNC-Lavalin. Next slide. Next slide, Barb. I'm going to talk a little bit about our sustainable business strategy and really give you a picture of our corporate policy in relation to sustainability and the journey that we've been on for the past 2 years. Our business is faced with a variety of risks. Some of these are predictable and increasingly they're becoming very unpredictable. So the key sort of societal megatrends that we have to address relate to shifts in economic power, demographic shifts, rising population, urbanisation, the rise of technology which changes all the time, and one of the major risks really relates to climate change and resource scarcity. Next slide, please. So we developed our sustainability policy statement and our sustainable business strategy. They're based around the UN Sustainable Development Goals. We're currently contributing to all goals and we've specifically targeted 3 goals that we're going to focus our improvement on in terms of business. Next slide, please. So I joined the business SNC-Lavalin in April 2018. September 2018, the CEO and ExCom members were appointed as high-level champions for key UN goals that are important to us, but also important to our stakeholders and clients. In December 2018, the board approved our sustainable business strategy. Could you go back 1 slide, please, if that's okay? Thanks very much. We'll also set up our data management system. And in January 2020, we made a link between our sustainable business strategy and our operational business strategy and growth. Next slide, please. So we've already got our policy, our sustainable business strategy. I'm working with teams to set up their corporate plans and reporting. Next slide, please. We've selected 3 goals that we're going to focus on. These goals are Goal 7, affordable and clean energy, Goal 11, sustainable cities and communities, and Goal 13, which is climate action. These are the goals that we're going to focus on growing our revenue streams, but they're also sort of the goals that we've found to be important to our stakeholders and clients following our materiality assessment. And the next slide, please. So this year, our CEO, Ian Edwards, appointed Dale Clark and Jeff Bell as executive committee sustainability sponsors. So Dale is going to be working alongside me to roll out implementation across the corporate sectors, and Jeff is working alongside me to roll out implementation across the corporate functions to make sure we've got a consistent approach across the entire business. So I'm going to hand you over now to Dale Clark, and he's going to talk to you about infrastructure. Thank you very much. Bye-bye.
Great, thanks, Sarah Jane, and good morning, everyone. Next slide, please. So I think it's fair to say that the COVID-19 pandemic has really impacted our lives in ways we'd have had a hard time imagining even 6 months ago. And it's really difficult to predict what the world will look like a year or two from now. But we've certainly seen a significant shift in people's behaviors that may transform our daily lives on a permanent basis. I mean, it's hard to currently imagine a simple handshake or any sort of mass gathering, but these sorts of things will likely eventually come back. But the way broader society functions, the way government agencies procure goods in the future, given the vulnerabilities we've seen in things like medical supply chains, and the way we move about using public transit, the way a huge portion of the population has had to work from home, conduct virtual meetings and sessions like we're having now, these may be long-lasting and permanent impacts. Next slide. So although the economic and social impacts related to COVID have certainly been, you could say they've been disastrous on many levels, there are some significant silver linings. And many of these are related to the possibility of a more sustainable future. So, many of us that are working from home certainly have seen significantly shorter commutes. For a lot of us, that's become a matter of steps, down the stairs or into a home office rather than a lengthy car or train ride. So with far fewer vehicles on the roads, global emissions have reduced, some say by about 8%, and traffic accidents have dramatically decreased. So this is really a time that governments at all levels can kind of capitalize on these positive trends and perhaps implement projects that are aligned with a more sustainable future. So some of these projects, maybe things like electrifying the GO train network in Ontario, that's one that we can think of that would be provide a positive sustainability impact, or maybe developing high-speed electric rail in the southern Ontario region. These are all projects that would continue to reduce emissions. Sorry, there's a question popped up there. I'm not sure if everyone's seeing are we seeing the slides at the moment? Barb?
I just put in a polling question about
Okay.
aging infrastructure because you were talking about infrastructure, Dale. So
Okay, perfect.
I encourage everyone to reply to that. Just see who has a plan for their aging infrastructure as we move forward in this uncertain period. I'll
Okay.
give it a minute and then we can move on with the presentation.
Okay. So just to wrap up that slide we were on, we can use advanced tools like digital twin technology to build projects as well. So we can look at all aspects of project development in the details necessary to achieve net carbon zero construction. So I'll just give a minute. Okay, Barb, you're pulling the slides back up.
I am. So let's continue
Okay.
on. We had 45% of
Great.
people vote.
All right. So let's go to the next slide. So this really is showing that the money is kind of there for stimulus spending. I mean, we've seen some big headlines, a few of them noted here on this slide. If we go to the next one, Barb. So here in Canada, there's also been quite a lot of chatter about stimulus spending and huge benefits from that. In fact, just yesterday, actually, the government of Quebec announced $3 billion for the acceleration of about 200 projects in various sectors within Quebec to help stimulate that economy. Ontario issued earlier this week RFQs for stages of development of the Ontario Line subway. Next slide. And these are all positive things. I mean, economic data shows that when 1% of GDP is invested in infrastructure, the economic output increases by about 0.5%, 0.4% in the year that that is invested, and that increases to about 1.5% 4 years later. And infrastructure spending, creates jobs for Canadians. It closes the infrastructure gap that we've heard about. And that gap has actually been limiting Canada's economic growth and Canadians' quality of life. So a lot of positive things can come out of the stimulus that may be applied to infrastructure. Next slide. We've been here before. If we look at a decade ago, there was a lot of stimulus by governments pumped into the sort of post-recession period. But at that time, spending actually set us back in terms of greenhouse gas emissions. We actually saw a 6% increase in greenhouse gases following the recession. Today seems a bit different. Most people would like to see an economic recovery that actually prioritizes climate change and sustainability. Next slide. So the level of investment that governments are making and that we're hearing about is really once in a generation level. It's far surpassing even what we saw a decade ago. So the choices that all of these governments make to restart the global economy will have enormous consequences in helping to achieve long-term social, economic, and environmental benefits. And these are benefits that are realized today and for generations ahead. So we've got an incredible opportunity to develop next generation energy systems, transportation networks, and a more sustainable future. So how do we do this? How do we align the major stimulus announcements we're already hearing about with getting the projects built? A decade ago, coming out of the 2008 recession, we saw similar promises, and yet the majority of stimulus funds weren't spent or were spent so slowly that they actually didn't provide the stimulus originally envisioned. So there's a number of issues that block that, that block projects advancing quickly. One's, the procurement process. P3 projects, for example, are very lengthy. Companies have to complete months worth of engineering before submitting a price. Supply chains within infrastructure are quite fragmented, so often the downstream, bidding processes and so on with those all take time. Projects often in infrastructure space are huge, they're complex, they may take years to define all of the details around them. And delivery in general of large projects is a sequential process. So starting with some form of preliminary engineering, environmental, community permitting, and then following through RFQs, RFPs, bids, detailed design, construction, etc. So in general, really lengthy processes to get projects shovel ready or really at the construction phase where most of the capital is deployed. So we've been looking at this issue and over the past several weeks, we've come up with an approach we call ASRI, which stands for Accelerating Shovel-Ready Infrastructure. So the next slide. ASRI, we've defined around 3 main pillars. So first is a capable owner, which includes a kind of a central planning concept to define, remove the blockers that I talked about earlier. Another pillar is capital investment. So it's aimed at innovative ways to get private financing into public infrastructure projects. And then the final one is an integrator type of approach to deliver projects in more collaborative and integrated ways where outcomes are ultimately aligned. Next slide. So we believe this ASRI concept will ultimately accelerate projects to market, enable lower carbon footprints, provide better capital and delivery efficiencies, provide more modern and productive methods of construction, and of course focus on zero harm to people and the environment. So lots of positives we think that can come out of this. We're really excited about this concept, currently discussing it with various levels of government as an opportunity for them to expedite shovel-worthy projects and jumpstart the economy post-COVID. So That's it for me. I'd like to now hand off to Kathy, who will talk about the nuclear sector. So, Kathy.
Great, thank you very much, Dale. Good morning, everyone, and thank you very much for joining us today. I'd like to give some insight into sustainability from a nuclear industry perspective. And I have a couple examples to illustrate the points as we go through. So the first example is how we are helping to extend the life of Ontario's CANDU reactors. Now, SNC-Lavalin is involved in Canada's largest clean energy projects. We are doing these projects in order to provide 30 more years of clean power. And this is very important because I don't know how many of you know, but nuclear provides 60% of Ontario's electricity. Two of the main projects we're doing are at OPG, Darlington Unit 2, which reconnected to the grid just this past May. This was a huge undertaking by a lot of people, and they really do deserve kudos for such a great job. Also, Bruce Power Unit 6, they started their retubing earlier this year. In order to support our clients and make sure that they meet their sustainability goals, we have been investing continuously in developing advanced tooling for these retubing projects. It's important that we continue this investment because it helps to reduce the schedule to help the nuclear power plants come back online quickly, and also it helps to increase the safety of the operators while they are undertaking the refurbishment projects. Now, as our fleet continues to, could you please go back, Barb? Thank you. As our fleet continues to age, we have to look at part replacement to keep the stations operating. And one of the things that we are undertaking is looking at obsolescent parts replacement to make sure that we have the part available for the stations when they need to replace it. I'm not sure how many of you know, but there is a really neat app and it's called GridWatch. You'll see a picture of it just to the right-hand side. And if you go and check on this app, you can see at any time what the percentages of the power or clean energy production in Ontario. And as you can see from this one, which was taken on Thursday, May 28th, about 60% was being provided by nuclear. So that's just a little neat app that you can go and check out to see how your power is being provided at any one time. I'll go to the next slide. Thanks, Barb. So another way that we are looking at meeting sustainability goals is in helping to reduce waste in operations. So I have two examples. The first one is our in-house developed diagnostic tooling. It's called the APPT, the Advanced Portable Polymer Testing. And this tool was developed so that we could test in situ power cables. And this will help us avoid unnecessary replacement of the cable. If we can show that the cable is still fit for service and can provide its safe operating function, we do not have to replace it, which can end up being very costly as well as result in excess waste. So if we can do that, we can avoid having any waste production. Next slide, please. So another way that we are looking at reducing waste in operations is by using spent fuel from other reactor types in the CANDU reactor. So we can directly use recycled uranium in CANDU reactors, and we don't need re-enrichment in order to use them in the CANDU reactor. In addition, we can blend the reprocessed uranium from light water reactors with depleted uranium, which is a byproduct of the enrichment process, and use both in the CANDU reactor to generate additional energy. This methodology helps to increase the total resource utilization, as well as it reduces the overall spent fuel per unit of energy generated. So we're always looking at new innovative ways to help reduce waste. Next slide, please. Another area that we're focusing on is decommissioning and waste management. So in the first instance, we are looking at enabling a site, once it has been decommissioned, to be able to be used for a reuse purpose. So this involves meeting the predetermined release criteria that is set out by regulators. And if we are able to do this, We could even use these sites for offshore wind development or even renewables. So repurposing them for a different energy productive use. We are also looking at waste minimization and looking at recycling and reusing materials when we are decommissioning. So some examples of this include our reuse of clean concrete once we undertake a demolition, and we can use this clean concrete to backfill basements, but also to landscape any sites. We are also looking at recycling metals, and we can introduce these clean metals back into the nuclear industry. So I think it would be pretty incredible if we could take metals from existing reactors, clean them, and then use them in the next generation of reactors we are building. Next slide. One of the things, as Dale mentioned, is COVID and how it's all kind of taken us back. But we have been looking at innovating ways to keep us operating. And one of them is using digital solutions. So I'll just give you a couple examples here, but we have many other examples that we are currently undertaking. So we've been able to continue to undertake site walkdowns and data measurements by using handheld laser scanners and a 360-degree camera. So all this involves is having one person who would maybe already be going into the site, take the tools and collect the data. This allows our staff back at home to utilize this data, and many staff can use it and many multiple times. It saves many trips to the station, but also in this COVID situation, it allows our work to keep going. We are also doing troubleshooting using augmented reality, and we can collaborate and work on designs remotely together, as you can see in the picture on the bottom right. So we are able to collaborate while we're working remotely in order to get the job done and keep us operating and helping our clients keep their operations operating. And then the next one is the CANDU small modular reactor. So this is an undertaking that we are currently working on. It is a 300 megawatt reactor, and it incorporates all the decades of experience and operational insight that we have from our CANDU international success. We are employing cutting-edge digital innovations in the design, in the operations, and all through the whole life cycle of the SMR. It is the most mature SMR design available in Canada, and it would help Canada reach its goal of net zero by 2050. It includes simplified systems and a modular design. It provides low-cost, low-carbon power, and it is included in a compact layout. And this is an all-Canadian solution and is shovel-ready by 2023. That concludes the nuclear portion, and I'd like to turn the presentation over to my colleague, Sebastian Musso. Sebastian?
Thank you, Katie, for a really interesting presentation. Today, I will present a few slides around dam safety issues and how good project planning that is taking into consideration sustainability objectives can help clients to overcome critical challenges in their business. The end goal of my presentation is to share with you a few slides and comments about the project SNC-Lavalin is undertaking in Ontario for the Government of Canada that is well aligned with some sustainable principles. But first, I want to give you a short overview of our dam infrastructures in Canada and in the United States and the impact of climate change on these structures. Don't be afraid. I will not do politics or start any discussion about what is causing climate change. Let's only recognize the fact that climate is changing. So let's start with an important definition. Dams are classified based on their hazard potential or anticipated consequences in the case of failure. So a high hazard potential dam is anticipated to cause a loss of life. Significant hazard potential dam should not cause loss of life, but will result in significant economic losses, including damages to properties or critical infrastructures. Then we have the low hazard potential dams that may cause minor damages to non-residential and unoccupied building or agricultural land. So in Canada, we have more than 14,000 dams. More than 1,000 dams large dams have a median age of 51 years old. In the United States, they have more than 90,000 dams, and the average age is 56 years. Out of these 90,000 dams, 15,500 are high hazard potential dams. What's scary is that in 2016, more than 2,000 high hazard potential dams were assessed as being deficient. Many of them are in bad condition and are not expected to safely withstand probable large floods and earthquakes. According to the American Society of Civil Engineering's more than 45 billion of US dollars of investments are required to address dam deficiencies in years to come. So a sustainable approach to this situation would be to rehabilitate these dams in order to meet current safety standards. Next slide, please. If we look at a map in the United States for some states, we can see that high hazard potential dams are being represented on these maps by red dots. In the West, we can see many high hazard potential dams in Washington, Oregon, and California states. It's the same in the east of the United States, in New York, Connecticut, and North Carolina states, where we have many, many high hazard potential dams. Next slide, please. You probably are all aware of the tragedy in Michigan a few weeks ago. After days of heavy rain in the region, the Edenville dams collapsed on May 19th. The dams were built around 1925. Interesting fact is that the license for the dam had been withdrawn in 2018 by the FERC because of insufficient capacity to withstand the probable maximum flood. Rehabilitation of the dams was being prepared, and construction was anticipated to start in 2021. On top of it, floodwaters also overtopped the Sanford Dam soon after. This is a great example of an old and not so resilient dam infrastructures combined with climate change impact that could have triggered a cascading failure scenario. Next slide, please. Consequences of this tragedy, the town of Edenville is severely affected. We have 3,500 homes and more than 10,000 people that are affected. And all of that during COVID-19 pandemic. Maybe it's time to start investing time and money in our old dam infrastructures. Next slide, please. My last slides will show you a good example of a project that relates to old dam infrastructures and climate change. The project is named Central and South Bundles, and it's on the Trans-Severn Waterway in Ontario, and our end client is Parks Canada Agency. SNC-Lavalin scope of work is mainly including engineering and design for replacement and rehabilitation of multiple dams and locks on the waterway, technical support during fabrication of mechanical equipment, and overall site construction support. Next slide, please. A little bit of background here. The Trans-Severn Waterway is a network of dams, locks, and bridges across 400 kilometers of central Ontario, linking the Georgian Bay with the Lake Ontario. The dams and locks were constructed between 1833 and 1920. The Trans-Severn Waterway was declared a National Historic Site in 1929, and they see more than 1.5 million visitors each year. So the general objectives of the projects are to increase flow capacities because of increasing maximum floods related to climate change, to improve operations and navigation across canals, and finally, to improve structural integrity, public safety, and resilience while protecting the historical value of these structures. I just want to point out on the left picture, massive sign of erosions of the upstream piers that could trigger stability issues. These concrete piers were built in 1910 and rehabilitated in 1943, and we're going to rebuild them from scratch with completely new piers this year. Next slide, please. If we have a closer look at key sustainability factors driving this project, the first key factor is the security of the asset. We have in this project old infrastructures right in the middle of populated areas in need of major repair that are redesigned and rebuilt to safeguard local communities. Another key factor was to safeguard species at risk. There are fish species, fish habitats, and many tree species that had to be protected during and after the construction. Good example of safeguarding species can be seen on the pictures of the Duro Dam 24 at Lock 24 site. You can see in this picture that we have used turbidity curtains to manage sediments in the water. Also, on the right of the dam, there is a sensitive marsh habitat with species at risk that we are protecting. Thanks, exactly. Next slide. Finally, the other key sustainability factors driving these projects are to create a long-lasting operational locks and dam capable of lasting 80+ years with regard to flow management and navigation, and to keep the existing historical and cultural value of the structure, which was totally paramount for all the stakeholders involved in these projects. So thank you everyone for your time. Patrick Sika of Mining and Metallurgy will be continuing the webinar on sustainability.
Okay, thank you, Sebastian. Very interesting content. So for the Mining and Metallurgy group, I'm going to talk about how we're helping clients maintain sustainability and actually improve sustainability of their operations. So I'm going to give 3 actual examples of what we've been doing at SNC-Lavalin. The first example will talk about off-gas capture and how we're helping clients minimize or eliminate off-gas emissions to the atmosphere. The second example will talk about acid plants and how we use acid plants to help generate power to power an acid plant and to power downstream process unit. And the third example will talk about our mine reclamation group and how we're helping clients decommission old mines and help them design for potential mine closure once the operations have finished mining. Next slide, please, Barb. Oh, just go back 1 slide, sorry, Barb. Yep. Okay, so the first project is a project we did for Vale called the Clean AR project, and that's an operating smelter in Sudbury which produces nickel. And the main purpose of that project was to improve gas capture and cleaning, and to reduce sulfur dioxide emissions by 85% and decrease dust and metal emissions in the smelter by 40%. And we did that by replacing existing equipment with more modern new equipment, improving existing equipment, and running off gas through bag houses and acid plants to make sure that the emissions weren't going to the atmosphere, but were going to the acid plant and the bag houses. Next slide, Barb, please. So the positive impact of this project, obviously it created about 500 local jobs. It was a $1 billion plus revamp project, so involved a lot of engineering and construction. The client was able to reduce SO2 emissions from 150,000 tons per year to 25,000 tons per year. That was a massive reduction. By doing that, we were able to effectively render what we call the super stack not required anymore. So the super stack in Sudbury is a stack that's about the size of the Empire State Building, and previously SO2 emissions would go up the super stack. In order to create draft to allow emissions to go up the stack, you have to have natural gas burners at the base. So we're now able to eliminate the super stack and eliminate the natural gas burners at the base of the stack, and that results in CO2 emissions cut by 40% in the operation. And the lower SO2 and lower dust emissions in the smelter are obviously good for the city of Sudbury, where people are not exposed to SO2, and obviously for workers in the smelter, where they're no longer exposed to SO2 emissions. and dust particulate. So it's a much cleaner environment to work in. Next slide, please. So this is a picture of the initial operation. So if you look at the middle of the slide, those are what we call Peer-Smith converters, and basically they're big cylindrical vessels that process mats. So originally there's about 6 converters in that picture, and all of the off gas is going up the superstack. So if you go to the next slide, it shows how we revamped the operation. So we took those 6 converters down to 2 converters, which are more efficient in operation, and then we run the gas through a gas cleaning plant, and then ultimately to an acid plant where sulfuric acid is produced, and the client is able to sell that as a byproduct. Next slide, please. So this is a picture of the original converter. We basically demolished 2 of these converters and put in 2 brand new converters. Next slide, please. So this is a picture of the new converter in the smelter. Next slide, please. This is a picture of the converter operating. You can see a primary hood has come down over the converter. So all of the main off gases coming off the converter when it's blowing go up through the stack system and into the wet gas cleaning plant and ultimately to the sulfuric acid plant. Next slide, please. And these are the secondary doors which close and capture fugitive emissions and secondary emissions. So you can see that the converter now operates in an envelope where all of the off gas is captured and scrubbed and cleaned, and the off gases are no longer present in the smelter aisle. Next slide, please. And this is a picture of our secondary baghouse, which we use to capture secondary emissions and dust particulate that could be present in the smelter. Next slide, please. And this is just an overall picture to show that the complexity of the smelter we were involved in. So it was a very old existing plant, and we had to interface in time with a lot of existing ducting in order to make sure that we captured the off gas correctly. Next slide, please. So I'll go on to acid plants now. So within SNC-Lavalin, we work with MECS DuPont to build acid plants around the world. The previous plant I showed you has off gas, and off gases can be captured and sulfuric acid can be produced. So that's one benefit of an acid plant. However, acid plants are also highly exothermic units that generate a lot of heat. So we capture that heat and we create power. So in a standard acid plant, we can recover 60% of the heat as high pressure steam. And in some of the more advanced heat recovery system acid plants, we can recover up to 97% of the heat. Next slide, please. So these are just a couple of pictures of existing acid plants that we've built over the past couple of years. Next slide, please. So an example where we can use power in an acid plant is in a fertilizer complex. So in a fertilizer complex, you have sulfuric acid that's produced. That sulfuric acid is used for production of phosphoric acid, and then down the line, we produce fertilizer. In a typical complex, a fertilizer complex, they need about 23 megawatts of power. A standard acid plant that produces 4,500 tons per day of acid can generate up to 27 megawatts of power. So the acid plant is generating enough power not only for operating itself, but for the downstream process units, and has extra power left over that we can sell back to the utility. So we don't have to create a power plant to power a fertilizer complex. We can use a process unit within the plant to power the entire fertilizer complex. Next slide, please. And this is just a graphical representation of a standard acid plant. You can see that there's a power export of 4 megawatts. And for an HRS type acid plant, we can generate up to 14 megawatts of excess power that's not needed inside the entire fertilizer complex. Next slide, please. And this is just a graphic that shows the carbon footprint for an acid plant in an overall fertilizer complex. You can see that it has a positive impact on the carbon footprint. Next slide, please. And finally, I'll talk about mine reclamation. So now when we're doing mines and new operations from clients have to consider eventual mine closure. So we help them develop mine closure plans. And then we also go into very old operations or decommissioned operations, and we help the clients reclaim those sites and close their tailings facilities. So if you go to the next slide, please, I'll show you 2 picture representations of a project. So this is a Poirier mine site in northern Quebec. And this was a facility that operated in the 1960s and 70s. And we were involved in helping that site be decommissioned. So we decommissioned the tailings pond. We ensured that water runoff was contained, and then we participated in revegetation of the site. So you can see on the left, that was the existing site with the tailings. You can see water pooling in the center of the tailings. And after we did all the reclamation work, we revegetated the site, and you can see the after picture on the right. Next slide, please. And this is another example of a copper zinc mine that operated in the 30s. There was a lot of runoff and pollution that happened in the surrounding water bodies. We came in and we cleaned up the tailings. We were involved in capping the tailings pond, and then again involved in decommissioning all the mining equipment and clearing the site and revegetation. So we created natural ponds, you can see there, and we restored the site back to more of its original state before the mine was built in the 30s. So those are just kind of 3 examples of what we do in sustainability, and I'll hand it back over to Barb now. Thank you.
Thank you, everyone. Really interesting presentations, and it's great to see examples of sustainability throughout all the different types of businesses and industries that we have here at SNC-Lavalin, but also within Canada. Now it's time for questions and answers. So please submit your questions if you haven't done so already. We have some great questions here. So the first one we will kick off with is, well, I guess it could be for any of our panel members. Based on a more nationalistic view on supply chains, is this COVID situation an opportunity to enhance local procurement and offsite manufacturing related to projects? Dale, maybe?
Yeah, sure. I can take that one, Barb. So I think, you know, this is a really good opportunity in how we actually do projects. So if you go back to what I was saying about ASRI and sort of modern construction methods and so forth, you know, we tend to, in major projects, we tend to specify equipment and materials, then go to the supply chain for bids and so forth. Maybe that can be reversed. You know, maybe we can be looking at, first of all, the supply chain and say, well, what can local procurement provide? What can local communities provide in the way of, you know, manufacturing local to a major development, a major infrastructure development, modules that can be used in that project, and kind of flip it around, and based on what we can see from the supply chain, the local supply chain, then design relative to that. And I know we do this in certain sectors, but I don't think, I think this is an opportunity to do that a lot more. I think there's going to be a continued focus on you know, sort of local procurement, local communities, reestablishing sort of communities that maybe have been affected by high unemployment through this COVID period. So yeah, I think it's a great opportunity for us to sort of rethink it a little bit how we do projects, and perhaps tap into that local supply chain and communities much better in the future.
Thanks, Dale. So the next question is for Sebastian. So there are some dams in Canada that supply power to both the US and Canada together. Did SNC-Lavalin have any studies regarding these dams?
Thank you, Barb. Well, I can think of the Moses Saunders Dam between Ontario and New York State. It's a huge dam that is kind of, half of it is being operated by OPG, and half of it is being operated by NIPA. SNC has been involved from time to time in rehabilitation projects and dam safety projects on the Canadian side of it, but it would be a pleasure for us also to work on the United States portion of this dam. We have offices in New York State, in Rochester, in Augusta, in New York. We have our people there, and for sure we can work. There are also discussions right now about interconnection between Quebec and New York State, and we are part of that. We are a really good and strong partner with Hydro-Québec, and we also have good relationship with NIPA. So yes, SNC is involved in kind of power sharing between Canada and United States. And these dams and this dam in Ontario and the interconnection in Quebec are good examples of these kind of relationship between both countries.
Perfect. Thank you so much. Kathy, so we have a question here about nuclear. So a long time ago, there was a nuclear project started in Alberta and Edmonton. Did SNC have any updates regarding that project? And perhaps you can give us an overview of if there are any projects in Canada that are coming up in the nuclear space.
So I think this is a great question, and funny enough, I was involved in that project. So thanks for bringing that back, and that was a really interesting time that I had working on that. We at the time, I think we were working with another partner, so that other partner did take that over. So I do not have any update on that project because we weren't involved in that project. So sorry, I can't give you any further update on that. But in terms of other projects, in my presentation, we saw the CANDU SMR, and we are hoping that that will be our next project in Canada, and we are actively pursuing that project. So I think it would be great to go along with the refurbishments of our CANDU reactors to also have a new build project on the horizon. Thank you.
Perfect. Sounds like an exciting time in nuclear. So Sebastian, another question. We have one about the Trent 7 waterway project and what has been the most significant undertakings to date, given we have done a lot of work and involved a lot of different aspects. So if you could just give a little bit of an update on that front.
Yeah, that's a really good question. And in my mind, there are many significant undertakings, but I think that the most significant undertaking to date was to successfully incorporate the heritage and cultural requirements established by our clients within the design of what is usually a plain, cold-looking concrete dam stuck in the middle of the river. We work with our clients to capture their needs. We try to ensure that the design criteria was met, and we overcame many of these challenges. But I can assure you that it was not an easy undertaking to work with these structures that are in historical sites being built in 1833 and to 1920. So it was a huge undertaking by a team, and it was a kind of a collaborative effort from different kind of stakeholders on this project.
Perfect. And there's another question about how would you start some discussions about the present dam conditions? So you obviously mentioned there are quite a few more precarious dams across US and Canada. So what sort of, what would you recommend to sort of review those dam conditions and move that forward in a discussion with management of the utility provider or owner?
Well, you see, the dam industry is a funny industry in the sense that some kind of provinces and states are extremely well regulated, and it's a little bit less regulated in other provinces. And I think that also there is some kind of differences versus public utility clients versus private owners of dams. And sometimes I feel that we should have standards and requirements that would be a little bit more the same everywhere. I'm going to take, for example, in Quebec, we have a law that is discussing and that is really strict about dam safety. But if you go to other provinces in Canada, well, there is no law, and it's a little bit more so-so the way it's managed. So in the United States, the FERC is kind of doing a lot of different regulation, but then it's to the states and to the owners to apply them. And we saw a good example on the Eden Dam that even if the FERC removed a license 2 years ago, well, it was too late. There was a disaster. So it's I think these situations, these kind of climate change and the impact of this, well, we have to trigger, and it has to trigger more investment. And we have to think that these dams that we don't often see, you see in the Trend 7 bundle, the projects are in our face. It's in the middle of Peterboroughs in cities, but most of the dams are in remote area and we don't see them. But if there is a failure, if it's the dam breach, well, the consequences can be terrible. So it has to start with the owners of these dams preparing a management project and make sure that we build resilience into these structures.
Perfect. Thank you so much, Sebastian. So going back to Dale, we have another question regarding shovel-ready projects. How do you see the procurement model or the award process for these type of projects?
Yeah. So first of all, the procurement model, I would be bold and say not P3. And the reason I say that is just because if we're looking at stimulus spending, the P3 model, which is not a bad model, I'm not sort of throwing stones at it, but it's a very, very lengthy process. You know, partners form when the first RFQ comes out. Typically 3 or 4 consortiums are each doing, you know, 30% engineering, which takes a year sometimes. They prepare a bid, and then there's the project agreement that needs to be developed and closed, and financing, and it's a really, really lengthy process. So I think we feel that a better approach is actually more of a collaborative framework. So there are alliance type of contracting models, IPD, which is integrated project delivery. They bring the parties together sooner. You know, you don't engineer 4 solutions to the same problem. You can do that right up front, get the groups together and integrate all of the key players and supply chain together. So that's the way we think is a fast, you know, a more efficient, let's say, way to, and faster way to get these projects aligned with stimulus spending.
Perfect. That's a great great insight. Patrick, so moving on to mining and metallurgy, in relation to mining technology, how do you discover or learn about new solutions and technologies? Do you work with universities, startups, accelerators, or have you got in-house teams?
Yeah, thanks, Barb. So we do work with universities in Toronto and Montreal. We're always looking at new technologies. We also have a number of technology suppliers that we work with, that we have close relationships with in a number of spaces. I mentioned the asset plant space, where we work with MECS DuPont. So they're always looking at developing new technologies, and we're showcasing those to clients and implementing them. And then we have a lot of in-house technology we develop as well. I mean, we're doing a lot of stuff remotely now, where we're using virtual reality, augmented reality, laser scanning. We're helping clients look at how do they improve remote operations more. So control rooms that are actually not located at the mine. There's a lot going on with underground mining, where operators don't go down the shaft and don't go subsurface. They operate the mining equipment from a relatively safe surface facility. So those are some of the things we're looking at with clients, and you know, we're always showcasing new ideas to clients on a regular basis.
Thanks, Patrick. So moving on from that, we've been using VR technology at SNC-Lavalin for a few years now. How has that been received by clients?
So I think with VR, clients like it. They recognize that it does add value. I think where it adds some of the most value is, you know, I'll give you an example. Typically, when we do a model review, for example, we have a model on a screen, and we go through it, and the client looks at it and gets an understanding of what the plant will look like. But we're now starting to do model reviews in virtual reality, where you know, the client can put on the headset and actually walk through the plant, look at you know, valve access, and get a more tactile feel of what their plant will look like. And we're finding that, you know, clients are giving more feedback. they're saying, well, my operators don't like this, can you do that? And that knowledge is coming from doing reviews in virtual reality as opposed to just on a flat screen in 2D. So we're able to involve operations much more and help the design meet what operations needs in the future. So I think it's being received very well.
Perfect.
Hey Barb, if I could just add a couple further points to Patrick's comment.
Of course.
Because VR is really a part of a sort of an ongoing shift towards digital, right? And sort of more and more digital technologies and tools related to projects in all sectors. Certainly, from an infrastructure perspective, there's, I would say, as a sector, it's been a bit slow to adopt compared to some other sectors. However, we are seeing more and more sort of digital twin type of technologies coming to light in infrastructure projects, and these are areas where and just the concept of digital twin, where we can sort of create a virtual sort of replica of the project in advance and work through all of the the sort of construction methodologies and bottlenecks, and look at basically building the project virtually and looking at how we can do this most efficiently and so on. I think that's a shift we'll see more and more into infrastructure space, and VR is a part of that. Once you design the project digitally, of course you can do walkthroughs and so on. So very good for people to see the sort of real experience that the project will ultimately bring as well.
Perfect. So thinking about government spending, traditionally they've built and invested money in transit. Do you think COVID-19 has changed the government's attitude towards investment in transit systems? And how do you think that will change in the future? So perhaps a question for Dale.
Yeah, it's a really good question, because and I think there's a lot of people scratching their heads about this currently. We've seen society really impacted from COVID in terms of the social distancing and all of that. So you sort of question, okay, well, what is the appetite going to be in society for a mass type transit systems? And you couple that with the fact that a lot of people have now dipped their toes into this working from home experience and actually found that it actually works out not too bad. So less maybe demand for transit as well. So I think the need is still there for transit development. It may be just different types of development. So there's certainly underserved areas. There's areas that are just total overcapacity, previously. So projects that continue to sort of take away those bottlenecks and so forth, I think we'll continue to see investment in those. I mean, this week, Infrastructure Ontario and Metrolinx announced the first 4 RFQs coming out with the Ontario Line subway. So that sort of fits into that category. But I think it's also an opportunity for governments to look at just different types of mass transit, period. There may be more appetite for autonomous vehicles or smart types of systems. We've seen some innovative solutions out there around things like autonomous pods that travel on guideways and things like that may not have sort of caught too much attention by governments in the past, maybe now will, and certainly can provide that solution of still moving people to areas of central cities and so forth, but can maybe do it in more isolated ways as opposed to mass ways. So I think it's a really interesting period we're coming into, where there's lots of potentially lots of sort of change ahead in the way we see transit.
Perfect. So that brings us to 12 o'clock, the end of the hour session. So I'd just like to thank all of our panelists, all of our attendees for coming today. Feel free to reach out to us. Here are our phone numbers for our Toronto, Montreal office. Send an email to cleanpower@sncloveland.com and it will get picked up. If we didn't get to your question today, please be assured that we will come back to you with a response. And we look forward to doing this again in the future. Thank you so much.